Welcome back, everyone. In this video, we're going to talk about calculating the Gibbs free energy via the second method, which is a little more the products minus reactants sort of thing, like what we have done with both entropy and enthalpy. And so method 2 is using appendix, in our textbook, this is not appendix B, this is appendix 2. And it's going to be taking the sum of the delta G of the products minus the sum of the delta G of the reactants scaled by the number of moles. And so we can use the table of the values of the Gibbs free energy of formation. And so to calculate our delta G of our reaction, and to do this for this reaction, we would take our 3 moles of KClO4 times the delta G of formation of that, which is negative 303.1 kilojoules per mole, plus 1 mole of KCl times the negative 408.5 kilojoules per mole for KCl. And we would subtract that from our 4 moles times our negative 296.3 kilojoules per mole for our KClO3. And so if we multiply this out, we get a negative 1317.8 kilojoules minus a negative 1185.2 kilojoules, which gives me a negative 132.6 kilojoules. And so that tells me that this reaction should be spontaneous, and it's rather spontaneous. 132.6 kilojoules is a decent amount of energy. So this method should seem familiar. You use the table and plug stuff in and scale stuff based upon the number of moles in the balanced reaction. Okay, so in the next video, we're going to continue working with the Gibbs free energy and talking about the concepts involved. So I hope these are helping.